So where are we at, guys? Which section?
3-2.
Yeah,
3-2.
196, 27. This gives you y. Y equals 2.5.
So I think we talked about those special cases, right? Number 37? No.
27.
27, all right. 27. Y equals 2.5.
Find the next one.
X and the y intercept. So this guy, what kind of graph this is going to be? I know it doesn't say graph it first, right? It doesn't even say graph it. But it's not a bad idea to kind of think about what the graph would look like. What letter's missing here? Careful now. Y must be 2.5. If I change y, what would like if I was at y equal 1? Isn't that here?
Yeah.
So let's say that's a point 0, 1. If I change y, if I make it 2, which direction do I go? I go up or down. This says y must stay at 2.5. What can x do? Anything it wants to. You guys see that? Because x is not there. It can do whatever the hell it wants to. That just says y must be 2.5. So can I go up or down? If I went up or down, y would change. So I can only move left and right, which matches up with x can do whatever the hell he wants to. Right? So y equals equation will be a horizontal equation, a horizontal graph. So there's there's my halfway points, right? So there's 2.5. So y equals 2.5. Just like that. Every single point on that line has y coordinate 2.5, right?
Yeah.
You kind of give yourself what point is that right there? 1, 2.5. That would be 3, 2.5, and so forth. So that's exactly what that says must happen. Y must be 2.5. So what is the x-intercept?
0.
Is there any x-intercept? If you say 0, you're telling me it hits it at 0. Does it hit the x-axis? Then you just say no x-intercepts. If you have an equation where the line is parallel to the x-axis. Now remember, these are the special cases. Special cases will always kick you in the ass if you try to look at them like they're normal.
Yeah.
This does not hit the x-axis.
Wait, why do you have 1.0?
He's just making stuff up.
No, I'm just doing that so you can see why it matches that. And I could do that if I wanted to. That doesn't change the fact that it doesn't hit the x-axis. So is there an x-intercept? No. There doesn't have to be an x-intercept, right? In fact, you guys, I'm sure, have heard or seen equations that kind of do like that.
Yeah.
Or good old parabolas. Does that have an x-intercept? No. It says, oh shit. So it's like, oh, it's got, oh, there it goes. A little comet. Here's my house. Yay!
Right.
Right? Thankfully, it did not intersect my house. It doesn't have to have any intercept. In fact, you can have much later in your math career,
So
maybe in 110, you guys will do circle equations.
What?
Does that circle have an x-intercept?
No.
Does it have a y-intercept? You don't have to have either one. What kind of intercept does this have, of course? And it gives you the answer right there. The y-intercept must be 2.5, because every freaking y is
No, it can't be
2.5.
No, it's no x-intercept.
No x-intercept. If you said the x-intercept was 0, you're claiming that this somehow, whoop, it doesn't go through the x-axis at all. So don't say x is 0. Say no x-intercept. Because it never comes down to the x-axis. It's always staying up here. Yes.
How would you write it down? It would be just y.
Now the y-intercept would be what?
2.5.
I like it. It would be 0, 2.5. Make it a point.
But that's 0.
That's 0. He's not saying
I don't care. I'm not sure what you guys are saying
No,
here
it's
now.
just showing.
To be on the x-axis, what must be true about y? And this might be a weird way to ask that question.
Put that 4 points.
How do you find the x-intercept of a given equation? Plug a 0 in for what? For what? Now think about what you just said. Y must always be 2.5. Okay, to find the x-intercept, I've got to make y 0. How can you make y 0 if y must always be 2.5? What does this say is 0? X. X can be 0. X can be whatever the hell he wants to be. Because the equation doesn't say anything about what x can do. It only says y must be this.
So you can actually put 1 or 3 in the bracket if you want to.
Say again?
You can actually, instead of 0, put 1 or 3 if you want to, or any number you want.
Where?
Like, you know how you
No. The y-intercept is when it hits the
I know,
y-axis.
but I'm saying, like, you graphed it 0.25. Can that 0 be any number? Because it doesn't hit.
No.
I'm so lost.
I
I
understand.
got it. Do you ready?
Now wait. Wait, guys.
I have a question.
Alright, let me get to you in just a second.
What?
Alright. Just hold on. That line right there. Where does it hit the x-axis?
3.
So what is the x-intercept?
3, 0.
Now, you guys are all cool with that. Where does that line hit the y-axis? It hits it at a point, doesn't it? The point 0, 2.5.
So you're
You
right.
can't make it anything you want to be. It's got to be on the y-axis. And if it's on the y-axis, I haven't gone left or right. So x must be 0. If x is 1, that means I've gone 1. I'm away from the y-axis. I can't do that. I've got to be on that axis. Now, don't get me wrong. These are good questions. I mean, these special cases are weird. Right? So it's a good question to ask. But
The answer is still no x-intercept.
definitely. That sucker does not dip down to the x-axis,
It's
does it?
not 0 because there's no intercept.
I like it.
But when you write it as a point, you have to use 0.
So what's the matter?
No, I just said when you write it as a point, you have to use 0. But there is no intercept.
There's a y-intercept, but there's no x-intercept.
Now I have a question for you. So, for instance, number 24, I got x-intercept is 0 and the y-intercept is 0. Can that
I
be
love it.
possible? Is that possible?
Definitely. If it goes, what's the one point that's on both axes?
The origin.
0, 0.
Okay.
So if I have a line that goes through 0, 0, that's automatically both the x and y-intercept because it's the one place they meet, right? So if you have y equals 0 as an intercept, then x equals 0 must also be in there. 0, 0, it's got to be both. I like it. Now, you had it earlier. Yeah, go ahead.
And then you're writing out, you write x-intercept, and then y-intercept, and point where you just say.
I love it. Exactly. So in this case, I just say no x-intercept. Don't say x-intercept undefined.
can't
It's not
put-
really quite right.
You can't put 2.5, like you're not writing 4 different points down.
No. There's only 2 at most intercepts that a straight line can have.
Okay.
Yeah. Right, one x-intercept, one y-intercept possibly. This one just had no x-intercept. Yes, sir.
So for number 30, since it doesn't give us anything, is it no x-intercept?
I love it. Number 30 is asking for the equations of the axes, right? It's not a part of that earlier problem set. It's not asking for an x and y-intercept. It's just saying what is the equation. So that is a definitely weird question.
You're killing me.
What is the equation of the x-axis? So like what would the equation of this line here be? Let me see if you guys get this based off of what we just did. So that equation would be y equals 3, right? What would the equation of this line be? I think some of you guys might see what I'm doing. What's the equation of the next one down? What's this line? Okay, what's the next one down is the axis. Well, what's that equation? Y equals 0. Right? Every single point on this axis, what's true about the y? It's 0. What point is this? Careful. 3, 0. What point's that? 2, 0. So what's the equation of the x-axis? Y is 0. Any horizontal thing is going to be y equals something. So the axis is where it's 0. It's at the ground now, right? What's the equation for the y-axis? X equals 0. Every vertical line is x equals something.
For the y-axis, it's x equals.
So for the y-axis, this would be x equals 0. Cool.
The only way to get y.
So let's do this again. Let's do this with the x's. So if I have this, what's the equation for this line? X equals -1. Not the intercept, but the equation. X equals -1. Because why do I know that's true? It's just trying to say the line can't go left or right. It can't go away from x being -1. That's the equation. And some people think that's way too easy, but that's what any freaking line equation says. Any of them. Give me a second. Let me expand on that. What does this say? Now this has both x and y in it, right?
Yep.
But the restriction then says, now there's a restriction on both x and y. Y can't just go crazy. Like here, x goes crazy. Here, y goes crazy. It could be whatever the hell it wants to be, right? Here, they both have to kind of together be something. They both have to be 3. So give me an example of a point that works there. Yeah, 2, 1 is on that line because 2 plus 1 is 3. So any equation sets a restriction on my x and y and says, you must do this. These are just kind of almost too easy in a way because it's saying x must be something. Well, what about y? I don't care about y. I didn't say anything about y. Like, you must clean your room. What about me? Oh, you can do whatever you want to. You're my favorite. Right? That's terrible. You guys with me here? I mean, here it doesn't care. Why? Why? Go crazy. I don't care. Do whatever you want to. 7? Yeah, you can be 7. -8? Yeah, you can be -8. 18 billion? Yeah, you can be 18 billion. I don't care. X, you gotta be -1. Oh, man. Right? So X can't go, oh, I go negative. No, screw you. You gotta be -1. All right? That'd be a terrible pair. What I do is screw you. Over here, this one, it's not going to be straight up and down. It's not going to be straight across because it has both letters. It's going to somehow be a slant. Because when one gets bigger, in this case, if x gets bigger, y has to get smaller, right? So here, this was 2, 1. What would 3 what? 3, 0. 3, 0. And of course, if I went backwards, what would, so 3, 0, 1 what? 1 plus 2. 1, 2. And then you can see the line forming there, right? So when there's a letter missing, it's going to be straight up or straight across, right? When there's both letters, it's going to be at a slant somewhere between those two. Cool. Very hopeful. This is weird, I understand. And actually, I tell you what, I mean, it would be easier, I think, if they would have done this, and I think they did this to you earlier. 0, 1, 2, 1, 7, 1, -4, 1, 6, 1. If you were to tell somebody, really quickly, what's true about this table?
Y is 1.
All right, that's why that's the equation, because that's the quickest way to tell people what these things do, right? What do these things do? Well, y's got to be 1. What about x? There's no pattern. It could be anything. Do you see what I'm saying? That is the equation. Whereas if I had this, let me see if you guys get this. Let me see. What's got to be true? Together they have to.
3.
Yeah. Together they have to make 3. Do you see that? So then this equation must match up with what I see is going on with the points. Very often we look at it backwards and say, give me an equation, let me graph it. When actually you can look at it this way. Given these points, what must be true about these two things? Well, together they must make 3. Whereas here, together, do they make something ever forever? No, they don't do anything. This guy's just got to be 1. This guy can do whatever the hell he wants to. I don't even have to say anything about him. You guys naturally said y is 1. Bam, that's the equation. Thank God it's what we hope it would be. Y is freaking 1. Okay, cool. Do this more. I went too far away. Any other questions that I could run with forever? Yeah.
51? 51? Or 3, 3?
3, 3.
Wait, so what was the answer to 30?
Oh, 30. What did I finish it?
Yeah, x equals 0 and y equals 0.
Exactly, right?
So the y-axis.
The x-axis is y equals 0. Because they're not going up or down at all. So y can't change from 0. It just gives you the axes, and that's all it's got to give you. It's just like me giving you this and saying, what's the equation of this line? I didn't give you much. But what is the equation of that line?
It doesn't give us
Well, number 30 says, what's the equation of the x-axis? So it gives it to you. And what's the equation of the y-axis? It gives that to you.
Right? That'd be x equals 2.
Yeah, this would be x equals 2.
if it gave you 2.
No, it's just getting.
True. But what did they give me then for this? 0. Because that's what it is, one of those axes, right? Okay. I'm hoping. Now again, if that's the only problem you're having with is those special cases, and you're okay with all the other problems in there, you're in a decent spot right now. Try to get on those special cases next. Right? If you're having trouble with the other stuff in here, that's when I'm really worried. Those special cases are weird. You can identify them and realize they're actually easier. It's just that when we try to put all the other stuff on top of it, they get hard. All right, so what was the 3, 3,
51.
51? 51. Oh, cool. Now this is sort of related. I don't think we've. Let's see if I'm right here. Okay, cool. What kind of line is this? X equals 6. I like it. Beautiful. You guys did like that. Here's a real quick thing too. Let me see if you guys like this. Whatever letter's missing, this will be parallel to that axis. Y is missing, it's parallel to the y-axis. If X is missing, it's parallel to the x-axis. How do you like that? Will that help you remember it? It's one thing to remember it, right?
Yeah.
So here, y is missing, so it's going to be parallel to the y-axis. It's got to be up and down at 6, right? What kind of slope do you guys think that has?
That's a wall slope, so it's infinite.
Infinite slope, I love it. It doesn't run at all, so it's rise of a run. If run is 0, that's undefined, but now we know it's infinite. That would be the mountain that I wouldn't want to climb if I was a new mountain climber, right? Just stick my toes in the cracks. I don't want to do that yet. I don't know what I'm doing. For those of you who can climb crack climbing. So this slope would be infinite. Cool. Okay. And the other extreme, what would be y equals something? Y equals 7? What's that slope?
Here it is. 0.
0. It's flat, right? 0 slope. Doesn't rise at all. So it'd be 0 rise over lots of run. That's 0. Who else? I think somebody had a question. You had a question.
Slope is m equals
y2 minus y1
All
over
right.
x2.
So there's no other questions. Let's do a little review over what we've done so far, and then we'll do some new stuff. So last time we looked at the slope, and we all kind of remembered. So the letter we use is m for the slope, of course, because there's no m in the word. So let's use m. I think in French, I can't remember the word, but it's from the French. So m equals, in English, it's rise over run. And the cool thing is rise rhymes with y's. So the y's go up top. So it's how much I rise, and like we said, when I change y, I go up or down. So that's why it's rise or fall. And of course, run must be the other dude. When I say wise is rise, run must be the other guys. So this is the one you use when I just give you points. So can you find the slope? So find the slope between -1, 4 and 2, -7. If you're not terribly comfortable with this, you can always label them and then just plug and shove. If you need to, you could say x1, y1. There's my first point. x2, y2. And now it's just plug and shove. If you don't need to do that, don't do it. Slope will then be y2 minus y1, -7 minus 4 over x2 minus x1, 2 minus -1. So the big mistakes I always see is people mixing up where the x's and y's go. So somebody will do -7 minus -1. Well, now you're mixing your y's and x's. They don't do that, right? And the other big thing I see is somebody goes here and then they go this way. That's why the equation is set the way it is. You've got to go the same way. If I do this minus this, I better do this minus that. I've got to go the same way. That's the only reason the equation is like that, to tell you honestly. Because did anybody do it the other way? Here I'll get what? Negative 11 over.
Three.
Now I could do it the other way. So there's my 11 over 3. I could do it this way. 4 minus negative 7 over negative 1 minus 2. Do I get the same answer? 4 minus negative is 4 plus 7. It's 11 over negative 3, which is still negative 11 thirds. Same answer. I don't care which way you look at it.
Does it work every time? Or-
It has to. Yeah. Yeah. And think about it. If I turn the top around, doesn't that change its sign?
Yeah.
Like 5 minus 7 versus 7 minus 5. If you turn the bottom around, doesn't that change its sign?
Mm-hmm.
If both signs change, won't that cancel back to the normal, to what it's supposed to be? So that's why you can do it either way, really. And people get confused about, I'll give them this, and they're like, well, which one's the second point? I don't care. You
So
pick
like-
whichever, it doesn't matter.
So basically, we don't have to remember like y squared minus y1. We can just do it however. Like
Yeah, you take a y minus that y, and then the same, you start at the same place, x minus the other x. It doesn't matter which one's x1, x2, yeah.
Okay.
Once you go in the same order.
I always got to be careful when I say that because I get my people who are a little bit more rigid with the way they want to do things. In that case, you label them, you throw it in the formula just the way it is. That's beautiful. That's beautiful. Or you can realize it really doesn't matter as long as I subtract the same way.
It's longer, but I can kind of know I have
Yes, which is a good feeling. Okay. So that's the slope thing. We look to see what we could do when there's a graph. And of course, then you can just count it, right? If I have a graph, what's the slope from here to there? So how much does it rise or fall?
Falls.
Depends on how you look at it, actually. So if you start at this point, it falls how much? 1, 2, 3, 4, doesn't it? So you're going to go, slope is rise over run. Falling is negative rising. Is that cool? That's kind of nice. It's direction. So if you rise, it's up. Fall, it's down. So down 4 over how much? 1, 2, 3. Right? So over 3. If I started at this point instead, which is sort of related to turning these things around, really. If I started at that point instead, how much do I rise? 1, 2, 3, 4. And then I go back 1, 2, 3, back 3. So you guys see the point I'm trying to make? When do I put those negatives in? If you fall instead of rise, or if you go back instead of run forward, right? Anytime you're going in the negative direction, you better put a negative on that piece. And are they the same? Yes, thank God. They're both negative 4/3.
That's just a faster way.
If I have the graph given to me, I don't need the equation. But if I don't have the graph, you're actually wasting time plotting the points then. I'd rather want a direct way to do it that way, which is cool.
Because the slope, you better get there and you better get back. Right?
Yeah, exactly. So I can go from here to there, and then I'm like, how do I get back to my house? Well, just undo what I just did, right? And I'll get back to my house. As long as there's no canyons in the way. Yeah.
If your slope's like 2 over 4,
Yeah, exactly. Anytime you can reduce slope, it's like taking a smaller step, right? So, I mean, if I, here's kind of a funny example. If I live, let me see if you guys are cool with this. I'm just kind of taking a, ultimate tic-tac-toe. If I live right here, and I want to go to the store, which is, well, let me put myself over here. And I'll go to the store here. I could say, okay, I want to go up 1, 2, 3, and over 2, right? Up 3 over 2. Or I could go up 1, 1, 2, 3, 2, yeah. I could go, I didn't want it to be a fraction, sorry. Let me do this. Up 1, 2, 3, 4 over 2, cool? I think you guys I want to do one like you said. If I can reduce it, what does that mean? But couldn't I go up 2 over 1? And up 2 over 1? Especially if there's something here I want to avoid. Like I look at my Google Maps and I see there's an accident there. I don't want to go there. Let me go up 2 over 1, up 2 over 1. So I can take smaller steps I'll still get to the same place in the end, right? So that's all the slope. If I can reduce the slope, it's saying, okay, you didn't have to take one big step. You could take maybe a few smaller steps, and you'll still get there. That's the cool thing about slope. It kind of takes into account how far away from the line you are. If I go way up here, then I'm further away from the line. I got to come over more. Whereas if I only go here, I've only got to go one over to get back to the line. That's what the reducing does for us. How important is all this stuff? Not very. I mean, the nuts and bolts of working this out, you don't need this. But the more you understand the concept, the easier a lot of these problems are.
So you can reduce slope and you're still, that's
Definitely, yeah.
But free flow, could be different.
No, that's the thing. The nice thing is mathematically it's not different, right?
You have to put in two cases have 2.1 to just go to your destination.
Going up 4 over 2?
I know, but if it equals 2.1 or 2 over 1, you're only going up 2 over 1.
Cool, but that's still the same line. And how long does a line go for?
Okay.
Forever.
Okay.
So I can go up 4 over 2. I'm not going to be the same place I was if I go up 2 over 1, but I'm still in the same line. That's the point. So if I reduce it, those are smaller steps. I'm going to need more of them. But it's still going to get me back
it's
to
the
the line.
same slope.
Same slope, same line. I like it. I tend to explain more than you're used to, I think. And it's more important to understand the concept behind these things. So I'm always
The
hopeful.
thing about I'm learning, like you just taught me the same stuff, but I didn't get it, but now I get it.
I'm hopeful. I'm always hopeful that's true. For some people, they're like, why does he say so much? Just tell me how to do the problems.
Sometimes I wish I would have heard this first.
Right.
And be in this.
All right, guys. So,
If I would have just kind of.
okay. So I want to make sure I didn't skip anything over. No. Oh. One last thing in section 3.3, and then we'll be getting into 3.4. The idea of parallel and perpendicular. Right? Parallel, perpendicular. First, real quick, how to spell parallel. You see the two L's look like parallel lines, so there's two L's, not two R's. So trust me, I can totally relate to misspelling. I'm not the best at spelling. One reason why I teach math. And then perpendicular, you just say perp, and that'll be fine. The symbol for parallel is this, not surprisingly. And the symbol for perpendicular, I don't know if you guys have ever seen that. That's the symbol for perpendicular. Right? So that might pop up or might not. I don't know. What's true about two parallel lines? They never touch. I love it. What does that mean then about their slopes?
They're always infinity. They're the same.
Careful, Lena. I like it. They're always infinity. This slope here is maybe 2 or something, right? The slope of this line
It's the same as the other one.
has to be the same. If it was any different, if it was bigger, it would hit it. If it was smaller, it would hit it back here.
Yeah, that's good.
Does that make sense? If they're parallel, the slopes have to be exactly the same. And I'm going to say it like that for a reason. So parallel lines. Let me actually show you how these symbols work. Here's line 1. Is that cool? And this is line 2. So we say line 1 is parallel to line 2. That's how you would use that symbol. Right? Math is really just another language. That's how you say that in math. So two parallel lines have exactly the same slope. There's a reason I'm saying that like, exactly. I'm making a point out of that. Because for perpendicular,
They don't.
Exactly.
they obviously don't. And yeah, the total opposite. How many ways to make something opposite do we know? Like what's the opposite of 1/7?
Negative.
Okay, one way to think of it is 7. That's the opposite multiplicatively. What's the opposite additively? Negative 1/7, right? So two perpendicular lines are negative reciprocals of each other. They change it every way you can think of. They change the sign and they flip. And let me try to show you why that's true. I'm not going to prove it because that's kind of ugly. Maybe a little more precise here with my lines. So this is going to be perpendicular. So if I had a line like this, can somebody tell me what the slope of that is?
1/3?
Yeah, it goes up 1/3. Is that cool? It's a very small slope, right? It's barely above the x-axis, so it's a very small slope. So that's got a slope of 1/3. Now, a lot of people say, well, I don't understand why it can't just be negative 1/3. Because we know it's got to be going the other way, right? It's got to be going down, and negative slope means going down. But why couldn't it be negative 1/3? If it was negative 1/3, wouldn't it be down 1/3? Does that look like it's supposed to be? What's true about perpendicular lines? They have to intersect in a perfect way. What does it mean to be perpendicular? How do they have to meet? What kind of angle do they make? 90-degree angle. Does that look like a 90-degree angle?
No.
No. So the truth is, it's actually got to be, if this is 1/3, the other slope has got to be negative. That makes sense. It's got to, if that's going up, this has got to go down. Reciprocal. And what's the reciprocal of 1/3? 3. And that would be like down 3 over 1. You see that? Down 3 over 1. Now that looks more like a right angle there, right?
Yeah.
So it's not a proof, but at least it shows you why it's not just making it negative. You also have to reciprocate it to make it meet at a right angle. You guys know that symbol there, that little box means right angle there, 90-degree angle. Okay.
So you did the opposite.
Yeah, whatever it is, the perpendicular one has got to be, change the sign, flip it, the negative reciprocal, right? So for example, let's do some quick ones in a row here. Mr. Who? Where? What?
Jeff? You wanted to ask me a
Good.
question.
Good job.
You already raised it, so.
Oh, I'm sorry, buddy.
No, it's not.
These things happen. So here, if M1 is -2/5, what would that be to be perpendicular?
Would it be -5?
5 over 2, positive 5 over 2.
You love it. Change the sign, flip it. It's just that simple. Very often in books they'll say when you multiply those it has to be -1, but I don't think that's very helpful. It's true, but it's not very helpful. To find the perpendicular slope, just flip it, change the sign. Right? So if one was 7, what's the perpendicular one?
Negative 1/7.
Good. Change the sign, flip it. -1/7. I love it. Okay, cool. So, we are now ready to finally get to what you know is coming, and that is the form of lines, the form of the equation. We actually haven't talked about mx plus b yet. So now we're getting into section 3-4. So, in an attempt to make this make sense, I'm going to do a couple examples. Try to get you to understand why, just because the number's in the right place makes it the slope or makes it the y-intercept. All right, some of you guys have probably done stuff like this before. Let's see, 2x minus 3. Let's do that. So help me make an xy table for this. So finish that xy table out for me.
What is that in the parentheses? Is that X or something?
Oh, that's an example.
Oh.
You there?
Yeah, I found an X or something.
It is in a way,
Yeah.
but it's nothing to worry about. It's not xy equals 2. That'd be a funky graph. In a very precise way, they meet at a 90-degree angle. Because you have a lot of lines that meet. Perpendicular means they must meet at a 90-degree angle. Cool.
So that means somewhere the point behind the same,
So you-
like right there, right? But you put a blue point on top of the black point. So that means that in some way there's one of the points are the same.
yes, exactly. If they meet, then one of the points must be the same for both lines. That point where they meet. That's actually going to be the point of chapter 4. Systems of equations.
No, no,
The intersection.
okay.
The intersection. Yeah. Because you have x, y intercepts, and then you have intersections.
Chapter 4 is also the shading.
No, that's the last section in this chapter here. Where we shade, yeah. That's coming.
And that one just happened to be at the origin.
Yeah, and that's just because I made it easy to do the slope. I could have picked the whole thing up somewhere else, yeah.
Now, how would you, so, going back, you graph this, so it's the reciprocal, so -3/1, so you just went over.
Yeah, I just went down 3 over 1. I just want to give a quick example of how this definitely wasn't 90, but this looks more like it's 90. It's not a proof, but at least it gives a reason why that makes sense. So what are you guys getting here for -2?
Negative
I like it. So twice -2 minus 3 is -7.
-5.
Twice -1, -5. I like it. Twice 0 minus 3 is -3. Twice 1 minus 3 is -1. Twice 2 minus 3, we finally get out of the negatives. Yay. Two things I want you to notice. What is the y-intercept? Just look at what we got here. Yeah, when you make x 0, the answer must be the y-intercept, right? That's how you find the y-intercept. So right here, this 0, -3 is the y-intercept. Where do I see that -3 somewhere else? Don't I see it right here? Right? And it's not a coincidence. If you think about it, if I make x 0, whatever the hell's there is going to be the answer, right? So if that would have been a +5, the y-intercept would have been 5. So whatever number is right there has got to be the y-intercept. Why? Because it's what's left when I make x 0. So that's an easy one to explain. Right? Whatever number is here has got to be the y-intercept, because it's what's left when I make x 0. Now that's straightforward. Here's the weird one. Every time I change x by 1, so see how I changed x by 1 here? X went up by 1. How much did the y go up by?
2.
Interesting. The y went up by 2. And I know it's a down arrow, but I hope it's just going to move through. Sorry. I changed x by 1 again. How much did the y change? 2. Every single time. That's the slope. Look. Rise 2, run 1. Right? Whatever number is right here, I call it my amplifier. Because whatever x does, y is going to do, in this case, twice as much. Do you see that? That's exactly slope. When I run 1, when x goes up by 1, y is going to go twice as much, and it's going to rise 2. That's why whatever number is in front of the x is the slope. Because it is. That's how it reacts.
Can you say that one more time? You lost me there for a
Okay,
second.
okay.
Try that again.
Are we cool with what I'm seeing here? Whenever x changes by 1, the output definitely changes by 2 at the same time.
Is that always? Like,
Definitely. And this is one specific example, but it could have been any numbers I want to put in there. It would have worked the same way.
So you could have put like 5, 7,
Totally.
12.
Yeah, whatever I wanted to here, as long as I made it easy to follow. In fact, look, watch this. Let me change this by 2. Let's put a 4 in there. See how I went up by 2 there, right?
Wait, but like 10.
All right, beautiful. I love it. Let's put like 10. So twice 10 minus 3 is what? 17. So how much did this go up by? Up by 8. How much did the y go up by? Double that. Right? Holy shit. But of course it has to, right? It's very rigid. This says this must happen, just like this. So any number that's in front of the x, when it's solved for y, is going to be the slope.
If you just subtract 2, instead of do all that work, just keep going.
Yeah, pretty much. As long as these are going 1 by 1, you can start here and then just add 2, add 2. I love it. Exactly. The more you understand, the less you got
Wait,
to
in
do.
this problem, are you looking for slope or y and x-intercept?
I'm showing why the y-intercept and the slope can be found just by looking at the
And
equation.
x-intercept is negative.
So this is where, exactly, in this case, this is where this equation comes from. That's where this equation comes from. Right? M is the symbol for what? Slope, right? So whatever number is here, when I solve for y, whatever number is here is the slope. Whatever number is here is the y piece of the y-intercept. Right? How do I find the y-intercept? I set x to 0. If I set x to 0, what do I get? B. 0b. So whatever number's there has got to be the y-intercept. So
You
y...
just said that negative 3 is x-intercept.
No, I said y-intercept. Right? Is the y-intercept. Right? Thankfully, I wrote it down so I could remember what I said.
And it shows the x-intercept too?
No.
And it's y-intercept.
I mean, you got to give it a break. It's good that it gives me two very key pieces of information, but it can't give me more than that.
So the y-intercept is -2 and the slope is 2?
Negative 3, and the slope is 2.
And the slope is 2.
So,
Okay,
Now-
so the x-intercept is any of those numbers, negative 2.
the x-intercept is the number I get when I set
Y is
y to 0. Right? I can't
So
see it in the
you solve
equation.
it
Yeah.
After you find y.
In fact, I could have made the equation for lines x equal my plus b, and that would have turned everything around. Let's not do that.
But the slope is just the number before the x.
Exactly.
Then why is negative 3 the y-intercept if it says y equals?
-3.
Because what do you get when x equals 0? You get y equals negative 3. The y-intercept is negative 3. 0, negative 3. So watch this. Here's where this becomes useful. Here we go. And again, whenever you take one of my classes, it sounds like a lot because I explain all of it. I could have just went straight to this and said the numbers in front of the x. I'd rather you understand why the hell it is.
Everyone else.
What do we know from this? I know. If you like that, you can go with it.
No, I'm just saying I don't like it.
Good. What do we know from this? Just looking at this, y is by itself. Be really careful. Y has got to be entirely by itself. If it's at 2y, I'm not done
Y
simplifying.
equals 1, right?
So what's that?
Y-intercept.
Y-intercept is 0, 1.
0,
This is the y-intercept. The y piece of the y-intercept. Okay, cool. And the slope is the number in front of the x. 2/3. Now watch this. Here's how we can use this to graph this without making an XY table. I can just look at the equation, pick these off, and graph it right off the bat.
before you do that, if it's just like, if it was y equals 2x plus 1, you would just make it to the fraction, 2 over 1.
Yeah, 2 over 1. If it's a whole number, you know you can put it over 1. There's an understood 1 down there. I like it. So here's how I can graph this. What point do I know is on this graph? 0, 1. You always have to start at a point you know is on the line. And the only point I know is 0, 1. So you can put that there. Get on there. And then what's the slope tell me to do from there? Up 2 over 3. So up 1, 2 over 1, 2, 3. Now, what's that point that I just ended on there? What point is that? Are you guys all cool with how I got there?
Yeah.
You plot a point you know is on the line, and normally that's going to be the y-intercept. Doesn't have to be. It could be any point, but we're going to know the y-intercept from this. And then you use the slope to get to another point. Because what's the slope do? It tells me how to go from the line back to the line again. So what's got to be true then? About that point 3,3. What's got to be true since the line goes through it? What's got to be true about 3,3? What's true about any point this line goes through? What does a line tell me very quickly? The line tells me all the answers, right? So the point 3,3 better work here.
Oh, you plug them in.
Plug them in. So you say, okay, the point 3,3 better work in this. So y equals 2/3 x plus 1. Is it true that 3 equals 2/3 3 plus 1? You guys with me?
Oh, okay, because 3 is added y is
So we got that point. Did we get that point by using the equation mathematically? Not really. We used it by just counting with the slope. So to check myself, I plug it in. Does it work? What happens to these 3's? And 3 is 2 plus 1. Thank God. So that point does work in that equation. So there's a way to check yourself. add this on.
Y1 is Y2, and X1 is X2, and not the same thing.
It would. You have to give yourself points first, right? So let's double check.
Well, if you take the slope and the y-intercept and add them together, it comes up to 3.
Be careful now. 2/3 plus 1.
I mean, if you're separate, the 2 obviously is going to be the y, the 3 and it's going to be the x. If you place them alongside each other and add them to the y.
I kind of see what you're saying. It's sort of like what we did just graphically. You're kind of doing it just numerically. It's the same thing though. I added 2 to my y and 3 to my x. That's how I got over there. Cool. And real quick, what's this point again?
0, 1.
0, 1. What's the slope then? Isn't it rise 3 minus 1, y2 minus y1 over x2 minus x1? 2/3? 2/3? Right? For some of you guys might realize, well, of course it's 2/3. It's how we counted up and over. Yes. Oh, this here?
Yeah, when you plug it into the actual equation at the bottom, you turn the x into 3.
Yes, 3, 3, x, y. So I put a 3 in for x and a 3 in for y. Cool. Yes. Do the one now? Sort of, yeah. But I want you to know why that works. Yeah. All right, let's try another one. Do it again. Let's see. Do it loud. Are you guys trying to get as far as you can with that, doing just what we just did? Identify the slope, identify the y-intercept, and then try to graph it. Yeah, do everything we just did, except for the get the slope, the y-intercept, graph it. That's all you got to do. Sure.
If this, I have a question about the negative though.
Yeah.
So, since it's on that,
I'm going to show you that. You can do the way it is. So we say down
And they go on.
and then over.
is it always run to the right?
If it's positive 5, then you run to the right. If it's negative 5 at the bottom, you go back.
But, so now
I'll
it
show you.
tells it, is it's going to be up top or at the bottom then?
You could put it either way. So the way it's written right now, you would go down and over. And if I put the negative on the bottom, you would go up and back. And of course, you got to be able to go back to where you were, right? So when you move the negative, you're actually not changing anything. You're just going the other direction.
But it doesn't matter because it's all.
Doesn't matter. Yeah. To me, I always go the way that if I have graph paper the other way, but not this way. Like if it's too high, I go, oh crap, let me change the negative so I can go the other way around.
Right.
Yeah. Oh, you good?
So once we use the graph, it
Yeah, you're good.
negative 4/5.
Good. So the slope is negative 4/5. Good. And the y-intercept is 0, 4 because of that. I like it. So b is the intercept piece, and n, the number in front of the x, is the slope. So what do you graph? Where do you start? I love it. The biggest mistake I see is somebody will put, somebody will start counting from the origin, and then they'll just put this point on there. So have a line with a point next to it. The slope only works if you start on the line, and the only thing I know about the line is it goes through 0, 4. I got to start there. So 1, 2, 3, 4. Bam, there's 0, 4. And the slope tells me to go
Down from that.
down 4, positive 5. I always get people confused. There's only one negative sign out there. They both can't be negative. You don't go down and back. Then the negatives would cancel. It'd be positive. But it's not. It's negative.
Give it to either one.
So either the top is negative, and I'll show you can actually do it either way. I wouldn't do it the other way right now because I don't have much room above. But let me give myself some room above. You guys don't have to do this. But if like this was the edge of my paper, I wouldn't do it the other way. So let's just do it the way I'm sure most of us did it. Down 4, over 5,
Yeah.
right? Is that cool?
Yeah.
Yes.
So you happen to end up on the x-axis. That doesn't have to happen. I just kind of made that. Cool?
So
And what's got to be true then about this? What point is that?
5,
0.
5, 0. And what's got to be true about it then?
that's
0.
When you plug a
0.
5 in there, you better get a,
0.
0.
and do you? Negative 4 fifths times 5. Bam, negative 4 plus 4 is 0. Check. I get y is 0, right? That point works. Now, watch this. I could have said instead, this is 4 over negative 5. You truly never have to do this, really. But I'd like to show you this makes sense. Slope is all about getting back to the line. Doesn't the line go in both directions? So I better be able to go both ways. So if I start here, what's up?
Can you do the bottom again?
So I plug a 5. If I plug a 5 in, what do I have to get out for y? 0. And did I?
Yes.
Yes.
Oh.
Cool.
Oh.
I can put a 0 there, but that's basically the same thing I'm doing. I got to show that this is 0, and it is.
Because how come we didn't plug anything from why we're there?
You could, but it's kind of like, you know, and then you get 0 equals 0. Yay. Right? Okay.
Alright.
Now watch this. If I look at it like this, what does that tell me to do from here?
Up 4
Up 4, 1, 2, 3, 4,
to the left.
and then back 5. So it'd end up like here. And that's just taking this and going further, isn't it? Not straight because my scale sucks, but oh. Hopefully you guys get it.
So either answer is right.
It's the same line.
Same slope.
I just need 2 points to make a line. What 2 points? Any freaking 2 points, right? Any 2 points in the
And the
line.
lines infinite.
Yeah, it's infinite.
And then in order for us to check to make sure the slope is right, we plug back.
One way to check is to take the point you got when you counted and plug it into the equation. If it works, you're good. If it doesn't work, you made a mistake somewhere. Okay.
Was there a right hand, like, when you
Well, here I would say the problem would say identify the slope and the y-intercept and then graph using that information.
okay, so I would.
So that's all I'd see this, and the graph. And that'd be good. Yeah.
And you can just check it like
Yeah, and then you can check it by plugging in a point. This point would be negative 5, 8, right?
Yep.
So we can check it. 8 for y, negative 5 for x, right? Don't the negatives cancel here? 5's cancel. 4 plus 4 is 8. Right? Okay. Let me see, make sure I don't skip anybody. So, what do you think you have to do when you get something like this here?
Yeah.
So same instructions, find the slope and y-intercept, and then graph. Knew it wasn't always going to stay.
Yeah. Yeah.
The only thing wrong with this, though, is what? What's the only thing wrong with the way they gave it to me?
Why isn't by itself?
Why it's not by itself? Which is one little reason why we had that whole section about working with more than one letter in an equation, because you have to. I have to get y by itself. I better not be freaked out that there's an x in there too. Oh well. I'll give you one little piece of advice. What's the first thing you would do to try to solve for y?
Can we use add 5?
Beautiful.
0.
Right? Here's the thing with the y in it. Let me get rid of the other thing I don't want. So let me add 5x. It's the opposite operation, right? Add 5x.
32 y is 6 plus.
Now you see how I put the 5x in front just so it's more like mx plus b? Okay. And the last step is, yeah, the big mistake I get here is people tell me the y-intercept is 6 and the slope is 5. Why is that not true? Because y is not by itself. When you divide by 2, do it this way. Don't put one big line because you want mx plus b. You want them separate, right? divide each thing by 2. That'll keep it in the mx plus b form. So this cancels. 5 over 2 is 5 over 2.
Plus 3.
Plus 3. Why don't you want to make this a decimal? Why don't you want to put 2.5 there? Because slope is rise over run. I want a fraction. Let it stay a fraction. Fractions in this case are nice. The top is the rise, the bottom is the run. I want a fraction. Right? One case where I want a fraction.
So the y-intercept is 3 and the slope is positive
0, 3.
Like 0, 3. Good. And the slope, of course, has to be 5 over 2. This is a really good place to say if you are anywhere near as sloppy as I am, get some freaking graph paper, right? The one thing I definitely don't want to see in the homework is number 7 there, number 8 there. What? You got to give me scale. You got to put your x, y. You got to show me some work. I mean, don't just give me this, right? That could just mean you know how to use a graphing calculator and just copy in the picture what it looks like. Yay, good for you. Your graphing calculator has passed. So where do I start? What do I put there first? 0, 3. And from there I can go.
I
Good. 1, 2, 3, 4, 5, and over 2. Now, if the top of your paper was here, you're like, oh shit, you don't want to erase the whole thing. I'm sorry. I was thinking ahead. My bad. So positive 2. So the whole thing. So if the top of the paper is up there, what could I do instead? Now this one's a little bit weird. And I was trying to think ahead in my head, but 5 over 2, here's where it gets a little weird, and you don't totally have to understand this, but it's the same thing as negative 5 over negative 2. Is that true? There was never a reason before to think about this. Mathematically, it's like, yeah, but why? But now it makes sense. Now, what does it tell me to do? Down 5. 1, 2, 3, 4, 5. Back 2. That's what I was thinking ahead. So then you can connect it up. See, that's still on the same line. Do you have to get that other point? No. Do you have to even understand what the hell? Not really. But it's kind of nice to see how the negatives play with us. So both of those points, if I wanted to plug it into the equation, it better work. Right? You can plug it into here, or you can plug it into here. They're both the same equation. So, here's kind of taking in that last thing we talked from the last section into here. Can you tell me if these are parallel or perpendicular? Or neither? Right, 2 lines could definitely be neither one. So these 2 lines I'm about to give you, are they parallel, perpendicular, or neither?